As a recap, Module 1 focused on linear functions, which are in the form of f of x equals mx plus b. Now we're going to move on to different types of functions. We will still need linear functions a little bit throughout the course. But now, specifically in these next 3 or 4 lessons, we're going to be focusing on quadratic functions. And a quadratic function, or also known as a second degree function, is a function that can be written in this form of this f of x equals ax squared plus bx plus c. And it goes on to say where a, b, and c are real numbers, but a cannot equal 0. What makes this a linear function is that this is essentially x to the first power. So now that I have a quadratic or a second degree function, what makes this a quadratic is that now I'm going to have an x squared in there, and that's going to be the highest degree. And so it says that a cannot equal 0 because if a equals 0, then you have 0 times x squared, which would 0 out. And now I'm just left with this bx plus c, which is essentially this right here. It's your linear equation. So a cannot equal 0. Now in today's lesson, we're focusing on graphing quadratic functions. And the graph of a quadratic function, f of x equals ax squared plus bx plus c, is called a parabola, with a turning point that's called a vertex. And that vertex is something we're going to have to be able to find. That's a big part of these quadratics. So I have a lot of this already wrote down. You can pause if you need to. But when a is greater than 0, or in other words, when a is positive, we are going to have a quadratic function with a graph that is concave up, which means it's going to open up. So I'm going to have a parabola that maybe looks something like this right here. Okay, and it says that turning point is called a vertex. So here's my vertex right here. So here it is decreasing, and then it gets to a low right here, and now it's going to start increasing. So that is my turning point. And when I have an A that is positive, meaning it's a concave up, that means your vertex is going to be a minimum. As you can see here, it's a minimum because that is the lowest point on this graph. So then opposite over here, when my A is less than 0, or when I have a negative A, okay, and notice both of these, A cannot equal 0 because we established that that would take out my x squared term. So when A is less than 0 or negative, now it's going to be concave down, which means it opens down. So I'll have something like this. And now my vertex, that turning point, is the top of this graph. And so now that is a maximum. Now it's going to be really important to be able to find these vertex points. And so here is how you find your vertex point. You're going to have to do this kind of in 2 different steps. So first you're going to find your x coordinate, and you're going to be using negative b over 2a. So what does this b and this a mean? Coming back up here to our quadratic, my b term is whatever's in front of my x, and then my a term is whatever in front of my x squared term. So typically they will do this as x squared x and then constant, meaning no x here. But it's not always going to be in descending order. So it doesn't matter the order it's in. A is always with your x squared, B is always with your x, and C is always the number without a variable. Okay, so that's what I'm talking about by that negative b over 2a. So that's going to give you just half of that vertex is going to give you your x coordinate. So then you're going to take that x coordinate and you're going to plug it into your equation right here for these x's to then get your y coordinate. And so these vertexes will always be in the form of x comma y, where we're finding our x point first and then our y. Now with parabolas, we have something called axis of symmetry. And your axis of symmetry is essentially your x coordinate. So notice that these are the same formulas. You don't need to find it twice. It's going to give you the same number. So whatever this x coordinate is will be your axis of symmetry. And your axis of symmetry will just go right there through that vertex. And so it means that what's going to happen is we can kind of use that as a check where that left side of that parabola should mirror the right side and vice versa. This left side here should mirror this right side over here. Okay, so pause that, write down anything you need to, and then let's go on to the next page, and we are going to be finding all of these things here. Okay, so example 1 says use the function f of x equals negative 2x squared minus 4x plus 6 to answer the questions below. So first, is my graph concave up or concave down? We can tell if it's concave up or concave down by looking at our A. If A is positive, it's concave up. If A is negative, it's concave down. So here, what is my A? A equals negative 2. It's whatever is in front of your x squared. So this is my A, this is my B, this is my C. So because my A is negative, that means this is concave down. So if I have concave down, you can either look at your chart on the next page or kind of draw it. Is the vertex of the graph a maximum point or a minimum point? Well, if it's concave down, means it looks like this. So that vertex is right up here. So this would be a maximum point, which is on this chart here. If it's concave down, the vertex is the maximum. So the vertex is at, we need to find the ordered pair for our vertex. So I am using my x equals negative b over 2a and then plugging that in for my y. So x equals negative b over 2a. So my b is negative 4. So if I have negative 4, that's going to equal 4. And then over 2 times a, we just said here, a is negative 2, or you can look right here, a is negative 2. So we get 4 over negative 4, and that gives me an x coordinate of negative 1. That is only half of my vertex, my y. So now that I know my x coordinate of my vertex is negative 1, I'm now going to plug that into both of these x's here. So I get y equals negative 2. Negative 1 squared. When we substitute in, we need to put that in parentheses. That's very big. Minus 4 times negative 1 plus 6. So you can work that out by hand if you want. I would probably just put this in our calculator. And we get 8. So my ordered pair is negative 1, comma 8. It's x, comma y. And then where's that axis of symmetry at? Our axis of symmetry is x equals negative b over 2a, which is what we just did right here. So our axis of symmetry is at x equals negative 1. Okay, pause the video and see if you can do example 2. It's the exact same. Okay, I hope you had time to pause the video. So let's go over example 2. Is this graph concave up or concave down? Well, if I don't see any number in front of that x squared, that means my a right here is 1. And because a is positive, because it's greater than 0, this is going to be concave up. So what does a concave up graph look like? Something like this. So is the vertex of the graph a maximum point or a minimum point? Well, here's my vertex. That's the lowest point on this graph. So this one is a minimum. So what is the vertex? We've got x equals negative b over 2a. We already established that a is 1, but what is my b? My b is this 8 right here. If I needed it, c would be 19. So negative b would be negative 8 over 2 times a of 1. So we get negative 8 over 2, and we have an x of negative 4. That's only half of my ordered pair. I need to plug that in to get the other half. So y equals -4 squared. And we're putting that in parentheses. That makes a huge difference. When you substitute in, please put it in parentheses. So -4 squared plus 8 times -4 plus 19. So let's see what we get. And I get 3. So where's my vertex? It's at x comma y, -4 comma 3. And so what's the axis of symmetry at? It's at x equals your x coordinate, -4. Okay, rewatch this if you need to. We're going to need all this information on the next page. We are going to be graphing a quadratic. So make sure you understand examples 1 and 2 before you move on to example 3, please.